Apple II forever, making life better and better. Apple II forever and ever, bringing the rainbow to you.
So, hi folks, I'm Stephen Heumann, and as you just heard, I'll be presenting about the SMB FST for GSOS. So that's kind of a lot of letters, but what does that mean and why would you want it? Well, an FST is a file system translator, which is the component of GSOS that allows it to access different file systems. And support for FSTs was actually one of the kind of new features in GSOS that it was designed to be able to support a number of different file systems. And it came with a bunch of FSTs such as disk file systems like ProDOS and HFS, several others as well, and also the Apple Share FST, which supported Apple Filing Protocol, which was a network file system. And so it did support this AFP file sharing, which was a pretty cool feature back in the 1980s when a lot of computers didn't have networking built in. And it could work with like Mac file servers and such back then. But at this point, AFP, and especially the version of AFP that GSOS supports, is very much legacy technology. There's essentially one maintained AFP server called Netatalk that you can still use with GSOS, but you essentially have to set that up on a Linux server, so it's not necessarily the most convenient thing for everyone to use. So, in comparison to that, SMB is really the file sharing protocol that's used by lots of modern systems. It comes out of the Microsoft domain, so it's used in Windows, but nowadays it's also the default file sharing protocol on Mac. And just for the sake of telling you, SMB stands for Server Message Block. That's not a particularly meaningful name, but that's what it stands for. So, this SMB file sharing protocol, as I said, is the modern file sharing protocol on Windows and macOS. It's also available for Linux and other systems. So if you had an SMB FST, that would let a GS connect to all these modern file servers, including pretty much any Mac or Windows system, or like NAS devices will essentially all support SMB. So it just gives you a lot of options for file sharing, and you can move data back and forth. It can be an easy way to get data to your 2GS, things like that. So back over a decade ago, in 2013, there was actually a prize offered for somebody to write an SMB FST. And I looked into it a little bit at that time. I know some other people did as well. I wasn't entirely sure whether it was feasible to write one, but I certainly thought it would be interesting to do. So that's kind of where it stood for a long time, at least as far as I was concerned. But more recently, I kind of came back to that idea. And I thought about some factors that make it maybe a little easier to write an SMB FST today than it would have been 10 or 11 years ago. And one of those, this was partially true 10 or 11 years ago, but there's more documentation out there today, which is that community members have figured out how to write FSTs. So Apple originally did not document how to write FSTs, and they said third parties were not supposed to write FSTs, but community members have figured out how to do that and documented it. Another factor is that you're going to need some crypto algorithms for at least the initial login part of an SMB connection, possibly stuff apart from that too, which I'll touch on later. But you need some of these crypto algorithms available. And so a few years ago, I did a project called 65816 Crypto, which essentially implements several modern cryptographic algorithms, cryptographic hashes, and AES encryption and such. So that's out there now as something that's available. Another thing is, I personally, for something like this, would prefer to write in a high-level language like C rather than assembly language. And so I've also updated Orca C, the C compiler for the 2GS, to support a number of new features and a lot of bug fixes. One of the significant ones being 64-bit number support, which is useful because the modern SMB protocol uses 64-bit numbers for various things like file sizes and some other things. And finally, there have been some tools developed that make for kind of an easier development workflow, at least for me. One of the key ones is Golden Gate, which allows you to run the Orca languages as cross-compilers on modern computers. Also the host FST, which is an example of a FST that a community member has been able to write. In this case, Kelvin Sherlock, he wrote both Golden Gate and the host FST that allows you to very easily move data between the 2GS emulator and the host system it's running on, which is just convenient for a kind of development workflow. So now that gets me to the SMB FST. And so I looked at those factors and I realized it was feasible, and I have written an SMB FST. So it allows the 2GS to connect to SMB file servers like Windows and Mac systems or Linux with Samba or NAS devices. And it supports basically all the file system operations you would expect on a GS. It's fully capable of reading and writing, and it supports things like file types and resource forks that are kind of part of the Apple IIGS file system model. So to just briefly go over the system requirements for it, you need just a 2GS with current system software 6.0.1 through 6.0.4. You also need Marinetti, which is the standard TCP/IP stack for the 2GS. And you need a Marinetti-compatible network interface. So in theory, this can be something like a serial dial-up connection or various different things. In practice, you'll probably want an Ethernet card. And so you can use an Ethernet or Ethernet 2 card, which are kind of the Ethernet cards available for the Apple II. And specifically, those two cards are the only ones that will currently let you see the list of servers that are on your local network. That's not strictly necessary. If you use some other interface, you'll still be able to access servers by typing the address. But basically, those are the ones that will work most conveniently with it. And now on the server side, as I said, Windows, macOS, Samba, which is the SMB server for Linux, also Solaris and Illumos, which is the modern derivative of Open Solaris. Those all have compatible SMB servers that I've tested, and those should all work with the SMB FST. So now I'll actually do a demo of it. And so we have a 2GS emulator here. We'll full screen it. And first of all, I'll just show you what the SMB FST actually is in terms of files. So we've got the disk for it here. And we've got smb.fst itself, which is the FST. You install that in the FSTs folder within your system folder. And then you've got the SMB control panel, so you install that in the cdevs folder in your system folder. And then just reboot your GS, and it should work. So obviously, I've got those installed already on this emulated system. So we just go to control panels here, and we have the SMB control panel. And we open that up. It's prompting us to connect to the network since we're not. So we do that. And then if we just wait a second or two, there we go. It's showing a list of SMB servers that it can detect. So in this case, this is an emulator. So it's using kind of an emulated network that's just detecting my MacBook here that I'm running the demo off of. And I've also got an emulated copy of OmniOS, which is an Illumos distribution that's also running on this same MacBook. So it's just seeing those systems. On a physical 2GS or an appropriately configured emulator, it can actually see systems, different physical systems on the network. But anyhow, we'll go ahead and connect the MacBook here, and it prompts you for login information. Name, password is pretty standard. Also domain, which is something that gets used in enterprise Windows networks. If you have an enterprise network, you probably know what domain it is. For home systems, you can generally just leave that blank. And also, you'll note there's an option to save the login information for the server, so you don't have to enter it every time. So I'll just enter. Enter that. I'll also save the login info. Log in. And once you log in, it shows you a list of the SMB shares that are available to mount from the server. So in this case, there are several different ones. There's also an option to mount the selected shares every time you start up the 2GS automatically, if that's what you want to do. We'll just go ahead and mount these now, mount all of them, because why not? And so now you can see they're all here on the Finder desktop. And these just look pretty much like a disk you can access. They've got this network share icon, but they're just like a disk. So in this case, this kind of shows some examples of different parts of the file system you might share. Like you can share your whole hard drive if you want to, which is what that is. You can have a public folder, which would be accessible to different people, including potentially guests if you've got configured to allow guests. You can have a user's home folder, which I've just set up this SMB demo user for this demo. So it just has kind of the standard Mac home directory things in there. You can do it that way, access your whole home directory. Or you can have kind of a special folder you set up as a shared folder, which that's what this GS stuff is. So we go there, we can see we've got a variety of files. We've got like a shrink-it file. This is actually the SMB FST installation file itself. We've got some 2GS applications, like a copy of the Finder and Animasia 3D. And so we can just say, we can go ahead and launch an application, just like you would if it was on your local hard disk. And it just launches like that. And once we're in it, we can also open files. You can see this dialog. It's saying we're on an SMB file server here. So we can open files off of that. For example, this Apple logo here takes a moment to open, but there we are. It's been loaded off the SMB file server. So quit out of that. Go back to the Finder. I'll just open this again. Okay, I'll also just show you can be connected to multiple servers at once. We have this OmniOS server. I already had the login info saved for that, so I didn't even prompt for it, but we can go ahead and mount that share. And now we have that accessible as well. So this SMB share, we've got a teach document on it. We can load that right up. We can change some formatting on it, like let's say we want it to have big text in outline format. Save that. It just saves, same as it would on any disk on the GS. We can close out of that. We can open it back up. We can copy files to it from it. For example, we can copy this copy of GS Shrink-it. That screen is not updating to show my screen. It's several seconds behind. But anyhow, we can open up GS Shrink-it, and once the screen updates, if it ever does, it will be open there. So just in general, you can do pretty much any normal file system operations you might want to do. And you can use it pretty much the same as you'd use a hard disk on your GS. But obviously, it's also a shared folder from whatever server you're running it from. So it's an easy way to move data back and forth between your two GS and modern systems. So that's really the core of how it works. It's just kind of like a disk that you can access over the network from your Apple IIGS. So, okay. Now, going back to the presentation. So it is available now on my GitHub. It's free, it's open source. I'll just go ahead and show you that. So here's the page on GitHub, if this thing ever updates. What's going on with this? Okay. What's gonna do? Yeah, this isn't working right. Yeah, fine. Yeah. Okay, there we go. There we go. Okay, so now we have the page on GitHub. You can just see it here. The download is right over here. The release SMB FST 1.0. You can see all the source code here if you want to look at it. One note, if you're trying to compile this, it actually requires the latest version of Orca-C that isn't actually released yet. So if you're trying to compile it as of right now, you actually need to get Orca-C from its repositories on GitHub and build that. Sometime within the next month or two, I'm hoping to do a release of Orca-C, and then you'll just be able to use that release. Apart from that, as I said, it is free. There is an option, though, if you want to sponsor me and give a contribution in support of this, there's an option for that there. Apart from that, there's the README for it, which just basically goes over some of the stuff I've talked about, installation, compatibility. There are some steps you need to do for setting up various different servers to work properly with this. So it goes into that in the README. Generally, it's pretty straightforward, but just check out those steps to set up your servers. And so now I'll go back into the presentation. And that was kind of the basic, how do you use the SMB FST? If you just want to go use it, you can download it right now and use it. But the rest of this presentation is going to get into how it works at a little more of a technical level. So first of all, I'll talk a little bit more about the SMB protocol and different versions of it. So as I said, it's kind of been the Microsoft file sharing protocol dating back to MS-DOS in the 1980s. SMB1 was kind of that original version of it, which they then kind of updated and expanded over time up to kind of the Windows XP era. And in the course of doing that, they made various changes and updates and added extensions to the protocol, because obviously something like Windows XP is very different from MS-DOS, and security needs were evolving and things like that. So because of all those changes, SMB1 became kind of a mess. And in the Windows Vista era, so like around the mid-2000s, like I think 2006 it was released, Microsoft came out with SMB2, which was a new redesigned protocol from the ground up. And that was based on the modern Windows file system model, so Windows NT-based versions of Windows, because that's all they were using by then. And so that's kind of the basis of all modern versions of SMB. And then from then on Windows 8, they added SMB3. The key new feature there is really an option to use encryption for the SMB connection. It's not required, but it has that option. And that's the main new feature there, which is probably why they bumped the version number of the protocol. But apart from that, it's an incremental update of SMB2, not a whole new protocol like SMB2 was. And then there have also been other incremental updates in subsequent versions of Windows, but basically all the SMB2 and 3 versions are essentially one protocol family with just fairly minor variations. And Microsoft has published a specification for how these protocols work, which was not always the case in the past with previous SMB protocols, but they have it now. So there's a specification you can work off of to implement it. And so that's what I've done. And the SMB FST supports SMB 2 and 3, not SMB 1, so only the more modern variants, but specifically SMB 2.0.2 through 3.0.2. And so those will interoperate with pretty modern versions of Windows or pretty much any other modern system that supports SMB. And so just to give you kind of a flavor of what the SMB protocol is like, I'll go over some of the protocol requests you can do. Negotiate is just what you use when you're initially connecting to a server and you want to negotiate what specific protocol version to use. Session setup is what you use essentially to log into the server, give it your username and password and stuff. Log off is the reverse of that. Tree connect is what you use to connect to a file share on the server, and tree disconnect is the reverse. Create is used both to create new files and to open existing ones. Close closes files, of course. You have read and write. You can flush any changed data, tell the server to flush data to disk. You can also query the contents of a directory. You can query and set info about a file, and a few other operations that I won't get into. So overall, I mean, these are kind of the normal file system operations you might think of. It's a reasonably straightforward, reasonably well-designed protocol. So now we get into the part of actually writing an FST to implement it. So as I said earlier, Apple did not document how to write FSTs. They said third parties were not supposed to write FSTs. So sorry to anyone who was in Apple if I'm stepping on toes here, but community members have now figured out how to write FSTs. And specifically, the Brutal Deluxe folks put out a RDOS FST, And Kelvin Sherlock has done a couple of FSTs that host FST that I mentioned earlier, and also a Minix file system FST. And those people have also provided resources and documentation about how FSTs work that others can use to write them as well. So specifically, the Brutal Deluxe folks put out a whole book called GSOS Internals, which goes over a lot of how GSOS works internally, including how it interfaces with FSTs. And then Kelvin Sherlock at KansasFest 2018 actually gave a whole presentation called So You Want to Write an FST that goes into a lot of the details of how to do exactly that. So that presentation is archived, you can look at it, which I would certainly encourage if anyone wants to write an FST. And Kelvin Sherlock has also open sourced the FSTs that he wrote, so you can look at the source code for those. So between all those different resources, it is now possible to write an FST, and so that's exactly what I've done. And I won't go too much into the weeds of how an FST works. As I mentioned, there's already been a previous KFest presentation on exactly that. But in general, it's going to translate GSOS system calls into SMB requests. So basically, you get out the Apple IIGS GSOS reference, and it's going to document the system calls, things like open, close a file, read, write, get set information on a file, list directory contents, things like that. It will document how those system calls work, and then you've got to figure out how to translate those over into operations that you can send to the SMB server. And so some system calls map pretty straightforwardly, for the most part at least, things like those read and write, open, close. You can see in that previous list of SMB operations I use, they map reasonably straightforwardly to between GSOS calls and SMB operations. But there are some complexities there. As I said, SMB is really operating on kind of a Windows-style file system model. GSOS has its own file system model with things like file types and resource forks that you need to support if you really want to enable it to fully work with GSOS programs that expect the file systems to support that stuff. So you need to kind of do a mapping of that to the Windows-style constructs in SMB. So I'll talk a little bit about how some of those mappings work. One obvious one is file names. You need to be able to represent file names back and forth to do anything with files. So SMB file names use Unicode. And specifically, they are up to 255 UTF-16 code units. So that's just a universal character set that contains pretty much all the characters from pretty much any language you can imagine. But the 2GS does not support all those characters. The 2GS desktop uses a character set which is also shared with classic Mac, and therefore it's called Mac Roman or macOS Roman, which essentially has your basic ASCII characters, plus most other characters that you would need for writing Western European languages. So for those characters that are included in the 2GS character set, the SMB FST will map back and forth between Unicode and those characters. It also uses a special encoding scheme for other Unicode characters. For example, if your file name is made up of Japanese characters or something, those just aren't going to show up correctly on the GS, but there is still an encoding scheme where it converts them into 3 bytes that will look like gibberish, but you still will be able to see that file and access it from the GS. And there are also a few kind of punctuation characters that are prohibited on Windows, and therefore prohibited in the SMB protocol because it's following Windows. But macOS actually supports those characters, and it has a convention for how to map them to characters in the Unicode private use area. So essentially, we just use that same convention, which means we can support those characters too. Like if you have a Mac SMB server and those characters show up in file names, they'll map correctly back and forth to the 2GS. And finally, one obvious thing is path separators. Windows, as we probably know, uses the / path separator. GSOS uses colons usually. It can also use forward slashes, but essentially the GSOS will map the file names you give to it to kind of a canonical form before it's passed to the FST, and that will use the colon separators. So then we can just map those to /. So that's the mapping for file names. We also have file attributes. So GSOS has these access bits, things like read enable, write enable, destroy enable, which means delete, rename enable, backup needed, and invisible. And SMB has a slightly different set of attributes, read-only, archive, system hidden, which these are actually the kind of Microsoft file system attributes, again, dating back to MS-DOS. So we can kind of map between those. So invisible and hidden mean the same thing. Archive and backup needed mean the same thing. Read-only is a little more complex. It means the file is write disabled and destroy disabled. That's what the dashed arrows mean. It's kind of reversing the sense of these. So you can map them back and forth like that. There are a couple slight complications to that, which is on SMB, read-only for directories doesn't really mean read-only. It means can't be deleted, but you can actually write files and delete files and change files within that directory. So just you have to check if it's a directory and change that mapping appropriately. And then one other gotcha with the file attributes is that macOS actually treats read-only differently than Windows does, which is what the SMB specs call for. But macOS maps it to its locked flag, which is something that macOS has for files. If you check the file info there, you'll see it. And that essentially means it can't be written to, it can't be deleted, and it can't be renamed. And that applies to both files and directories on macOS. So we just have to check if the server is macOS. There's a way we can kind of check that in most cases, at least, and then map these attributes differently accordingly. And one other thing I should say about the attributes is essentially this read-only flag is the only kind of access control attribute that we directly handle in the SMB FST. But obviously modern file systems have a lot more complexity than that. Windows has a system based on access control lists. POSIX systems have file ownership and modes controlling who can read and write a file and access it. So those aren't directly represented on the GS, but the server is still ultimately responsible for enforcing whatever permissions it needs to enforce. So there may be cases where, like, you can't access a file on the GS, you get an access denied error because of some of those permissions on the server, even though you can't really directly see them on the GS side. So that was file attributes. Another thing is dates, like creation and modification dates for files. So SMB, again following Windows, represents these dates as a 64-bit count of 100 nanosecond intervals since January 1st, 1601. So this is just kind of what Microsoft decided to do for representing dates. That's what, as I mentioned, that's the use of 64-bit numbers. That's one of those cases where it's handy to have that supported in the compiler. But we can map that to and from the GS. The sort of complexity there is that the SMB server will be using a UTC, universal time, whereas the GS uses local time. The way we can map between those is that when you first connect the SMB server, the server will actually tell you what it thinks the current universal time at that point is, and you can essentially compute the difference between that and the two GS's local time to get that difference, which is essentially the time zone offset, and convert the dates back and forth that way. So those were kind of pretty basic aspects of file metadata. Now we get into kind of the more 2GS specific stuff. So first of all, resource forks. That, as you may know, is kind of just a separate stream of data, separate from the main contents of the file, but also part of it, that can be used on GSOS and is used extensively. It's also used on classic macOS. And because of that, there's actually an existing convention of how you map resource forks over SMB. And this is used by macOS, but it actually originally dates back to the Windows AFP server. So you recall AFP is the older Apple filing system, their network filing protocol that back in the 1990s, Windows actually had a server for that protocol. And to deal with Mac and potentially Apple II clients at that time, they needed a convention for mapping these resource forks. And the way they did that is with what's called alternate data streams. So alternate data streams are a feature of Windows file systems like NTFS It's actually sort of like resource forks, but more flexible. Because instead of just having one resource fork, you can have any number of these alternate data streams that are identified by different names. And so specifically, the convention is you use one called AFP_resource, and that just holds the resource fork. And when you're opening a file, there's just an option you can specify, open an alternate data stream instead of the main stream of the file. So that's actually reasonably straightforward. And again, this will interoperate, like if you have files on a Mac with resource forks, it's the same representation, so it will interoperate with that, and you can move them back and forth. One thing is that this does require alternate data streams to be supported on the server, which, as I mentioned, Windows has that support built in. macOS has it built in because it will just essentially map it to the resource fork. Solaris and Illumos also support it. Samba, you need kind of this extra module called VFS Fruit. So you have to set that up in the Samba configuration. And the README has instructions on how to do that. And so following on from resource forks, kind of the other major option of kind of Apple or 2GS specific metadata is file types. So, and also Finder info, which is more of a Mac thing, but is also supported on the GS. So with that one, the Mac Finder info is actually how the classic Mac represented file types. It contained what's called the type creator code, if you're familiar with that from classic Macs. And essentially there's a defined convention for mapping between that and the 2GS style file type, which is done like in the HFS FST. So you can represent it that way. So there's another alternate data stream by convention that holds that Finder info, and it can also optionally directly hold a ProDOS style file type. So that leads us to do how we can get and set the file types, which is essentially we kind of do a three-step process. If that ProDOS style file type and aux type is directly present, then we just use that. If not, we can compute it from the Mac type and creator code like the HFS FST does. And finally, if neither of those are present, we can try to infer the file type based on some common extensions, like text files, for example. So between those, we try to assign file types to as many files as we can. And one other note here is that the Mac includes an extension to SMB to include the file types in directory listings. So when you're listing files in a directory on a GS, you will usually want to know what their file types are. And so with this representation based on alternate data streams, you would essentially have to open that alternate data stream, which is essentially the same thing as just opening a file, then read the file type out of it and close it for every file in the directory. So that can just be kind of slow. So we'll do that if we have to do that, like on Windows, we have to because it doesn't support this extension. But if possible, we'll use that extension to make it faster. So that's kind of the basic mapping of file system operations. There are some issues, though, that come with kind of compatibility concerns. And one of the big ones is the Finder. So obviously, the Finder is kind of your core application for managing files on the GS. So you want to support it. But it has some limitations that, or rather some assumptions that are true for all the file systems that GSOS natively supports, but not necessarily for SMB. So one of the big ones is it limits file names to 32 characters, because that's as long as anything could be. Like HFS only has 31 characters maximum. And so if you have a file name longer than that, it will display the characters beyond that as garbage. And in some cases, if it's long enough, it can actually cause the Finder to crash. And Finder also has some issues with displaying large sizes for files and volumes. Like you can see, I've got an example here of the Finder information bar, where it shows the used and free space for a volume. And so if those sizes are large, it can have issues, or the size of an individual file can have issues. And finally, Finder versions prior to 6.0.4, like for example 6.0.1, will display garbage for unknown FST names. So you see in that Finder info bar example there's actually kind of a blank space on the left of it. That's where the FST name would go if the Finder knew it. In the case of SMB, the Finder doesn't know about it because obviously it's a new thing. But like if you had like ProDOS file systems or something, that would go in that space. And prior to 6.0.4, Finder would actually, instead of just leaving it blank, it would display garbage there for unknown FST names. So the SMB FST will actually detect if it's being called from the Finder and kind of fudge the data it returns to work around some of these issues. Like it will truncate long file names, it will limit the sizes that it reports, and there's a way to make the Finder use an alternate style of the information bar where it just has the count of items and not the other stuff. So it will use that to avoid showing either garbage for the FST name or invalid used in free space numbers if it knows that the Finder can't handle those correctly. So up to there is kind of how we represent file system operations through the FST. But we also need to do some other things to actually connect to a server and use it. And one of those that I demonstrated earlier is finding the SMB servers on the local network. And historically, there have been several protocols used for that. Microsoft used to use something called NetBIOS plus the browser service, which essentially they've deprecated at this point and kind of disabled by default. Nowadays, Microsoft uses something called WS Discovery. But there's also a separate protocol called Multicast DNS Service Discovery, which that's one that was invented by Apple, so it's natively supported on macOS. Nowadays, it's also on many Linux distros and NAS devices. It's not natively on Windows, but you can install Bonjour, which is Apple's trademark name for their implementation of this. You can install that on Windows, and if you do, you can get it working there. And so essentially what that means is the 2GS will send out a packet on the network that says, if you're an SMB server, reply to me saying you're an SMB server. But instead of just sending that to one other system on the network, it's sending it to all the systems that participate in this multicast DNS. And so to do that, it needs to be able to do multicasts, that's sending to multiple systems instead of just one. And so I had to actually update the Ethernet and Ethernet 2 link layers to add support for that. And I worked with Heumann, the maintainer of those link layers, so thank you to him for working with me to do that. And now another thing we do after we list the servers, if we connect to one, we have to authenticate with it. And the SMB can use multiple different authentication methods. In practice, you use either one called NTLM v2 or Kerberos. Kerberos is the more complicated kind of enterprise-oriented one that uses a separate authentication server. We don't support that at the moment. We only support NTLM v2. So that one communicates directly with the SMB server. It uses some cryptographic operations based on the username, password, and domain that you entered to authenticate with the server. One issue with it, though, is that it is an older protocol that uses some older encryption primitives and kind of doesn't fully follow modern best practices for security. So because of that, Microsoft is kind of slowly trying to deprecate NTLM v2. So as of now, it still works by default on Windows and pretty much everything else. But at some point, that may go away. We may have to do something else. But for now, it works pretty well, which is actually convenient for us because part of being an older protocol is that it runs pretty fast. And so the speed of it really isn't an issue, even on an unaccelerated GS. So that's what we're using for authentication. Something tying into that is message signing. So the SMB protocol has an option to cryptographically sign the protocol messages that are being sent back and forth that allow each side to verify that the messages are coming from the other side and haven't been modified by some malicious third party in transit. And so essentially that's running these cryptographic operations to generate a message authentication code and include that with every message. So some SMB servers require that by default, others do not. Right now, macOS requires it. Microsoft, I believe, is moving in the direction of requiring it in Windows. So in order to be compatible with those servers, the SMB FST does support this message signing for the messages that it sends out if the server requires it. But that is going to impose a performance cost. So for best performance, you would want to disable that requirement on the server, and the README includes some instructions for doing that. One other note, the server can also sign the messages going to the 2GS, but the SMB FST just ignores any signatures there. because it doesn't want to spend the time checking them. And now kind of the last step of the connection process is listening the shares on a server. So this relies on the remote procedure call functionality, which is actually kind of built into the SMB protocol. So essentially there's a way that you can use read and write operations more or less the same as if you were reading or writing a file. But what that's actually doing is sending remote procedure call requests and receiving responses. And so there's a whole protocol for how this works, and many remote procedure calls that are defined on Windows. So this is a pretty complex thing in its own right if you want to get into it. But the SMB control panel only uses one kind of remote procedure call, which is just a call to get the list of shares from the server. So that's what we do with that. And so that's essentially the process of actually connecting to a server. And now I'll just mention, I won't go over all of these in details in the interest of time, but basically every server you try out has its own bugs and quirks. You can read the protocol documents and try to implement something based on the protocol documents, but you will find there are bugs and quirks on each individual server that you have to find and address by actually testing against it. And so that's certainly been a significant part of the work here. And I won't go into all of these. You can ask me about them if you want, but these are just some of them too. There are certainly more than that. And now I'll just kind of list some of the references that are involved in implementing SMB, just to kind of give you a sense of what was involved in it, and also if anybody is trying to look at the code and figure out what it's doing, you'd want to look at all these references. So you have references for kind of the core SMB 2 and 3 protocol. Then you have references for authentication using the NTLM v2, and it has encapsulations and data encodings that get used by that. Then the RPC calls that we use for listening the shares. There's a whole specification of how RPC works and its data encodings, and the RPC calls specifically for an SMB server. And then also the multicast DNS stuff, the RFCs that specify that. And on top of that, the crypto algorithms have their own specifications. As I mentioned, I'd already implemented most of those in the library, but you have to refer to the specifications for that. And obviously the documentation for GSOS, both in terms of the third-party stuff on how to write an FST, and the GSOS reference itself that documents all the calls that you'll have to support. And so that's basically kind of an overview of what's involved in implementing SMB and what you'll need to refer to do that, or to understand the code for it. And finally, I'll just thank people who have helped with this. First of all, the Bureau Deluxe folks, Antoine and Olivier, and Kelvin Sherlock have written other FSTs and provided documentation for them. So obviously that's kind of the foundation of how people outside of Apple can write FSTs at this point. Also, Wanop, who I worked with on those updated link layers, and I've had several beta testers who have provided helpful feedback and bug reports. So I'll thank them for that. And now I'll just conclude, and I'll show the link again. It's available today, so get it and try it out if you want. Any questions? Yeah.
Do you think the MDNS code will be factored out to the library or something like that? Because I would think that something like Tree Hunter, for example, could use that to detect network printers or other applications in the future could even find each other from the network.
Okay, so the question was, could the MDNS code be factored out to a library and be used for other applications, like, for example, Tree Hugger, like finding network printers or something like that? The answer is yes, potentially. I mean, the MDNS code is kind of in its own directory within the repository now, so it's kind of separated out as it is. You can look at that. It could potentially be factored out better, either by me or by somebody else, but yes, that could potentially be used for other applications. Okay, yeah.
With the proper cable, can I use this to talk to or look at files on my smartphone?
I'm not aware of an SMB server available for smartphones. I mean, like, if you have like a unlocked Android device, that's essentially Linux. It might be possible to get an SMB server running there, but I'm not familiar with what that would involve. iPhone, I don't believe it has it. Yeah. Ken?
You listed some Windows and macOS bugs and quirks. Does your FST expect those? Like, does your FST need to be updated as Windows and Mac are updated?
I mean, potentially. Okay, so the question is the bugs and quirks in different server versions here. Like, does the FST need to be updated as those change if they kind of have new bugs and quirks? Yes, potentially. I think though they aren't evolving that quickly. They aren't introducing that many new bugs and quirks. So like I've tested this from Windows 7 up to Windows 11 and a variety of Mac OS versions. So for the most part, I expect it'll probably keep working without needing to address new issues. Okay, back.
It looked pretty snappy performance-wise. Any sense compared to CFMB and you're actually launching programs over the network versus like a local storage device?
Okay, so the question is kind of about the performance, like comparing launching something over the network to a CFFA or something like that locally. It's probably slower than a CFFA. I mean, that demo I was doing was using a fast emulator on my modern system, so it's not really reflective of what the performance will be on a GS. It is definitely usable even on an unaccelerated GS. It's probably slower than something like a CFFA though. I think it'll be a little bit faster than AFP file sharing over Apple Talk, but not probably the speed of a CFFA.
All right, thank you.
I think overall people are amazed by the scope of work, and there's a couple of questions over in Discord right now. First one is about FujiNet support. Have you considered supporting FujiNet potentially as a link layer?
That's up to the FujiNet people essentially. You would need it to be supported either as a Marinetti link layer or something that works to provide the Marinetti APIs. And I'm not sure if that would be feasible in FujiNet, but if they were able to do that, then it would just work with the SMB FST.
There's one question about the S prize. Can you remind us what that is again? Yeah,
that's the prize that was offered back in 2013 for somebody to write an SMB FST, and it accepted contributions from a number of people. So as far as I know, this basically satisfies the conditions of the S prize. And that was kind of part of my motivation for writing it.
Yeah, thank you. Sheppy, the S prize administrator, is aware of it, and I think he's busy with personal issues at the moment, but we'll come back and share his thoughts on that.
Yeah.
Thank you again for your fantastic work. There's just a good discussion happening over in Discord right now. Someone has shared the exact list of Marinetti, TCP, and the link layers that are needed for support. Any final things you'd like to share?
I think that's it. Just thank you for having me, and enjoy the SMB FST.